Now the first portion of Chapter 6 just kind of introduced the normal probability distribution, but here we're going to actually make use of it. There's a problem that's in the PowerPoint slides in this portion about the PEP Zone Auto Parts and Supplies store. It has to do with the motor oil. When the level of that oil, when it drops down to 20 gallons, they reorder. But during that period, while they're waiting for some more oil to come in, they have demand for oil. And the manager is concerned that that 20 gallons, that may not be the right amount for the reorder point. They're thinking that there could be some sales that they're going to lose because they don't have enough. So they looked at how much demand they had after they reordered during that replenishment period, and they found out that the demand was normally distributed with a mean of 15 gallons and a standard deviation of 6 gallons. So they're reordering when it gets down to 20 gallons, which is above what the mean demand level is. But you expect 50% of the time that the demand is going to be above the mean. 20 is above the mean, but what's the proportion of time, or what's the likelihood that that 20 gallons, it's not going to be enough, that the demand is going to exceed the fact that they're reordering when they just have the 20 in there. But rather than just clicking through the PowerPoint slides and going through this process this way, I'm going to do this a little bit different way. We're going to come up with these same problems, and I'm going to go through and show you how to solve these same problems, but I'm going to do it in a slightly different order than what they do it here in the PowerPoint slides. So let's go to the different application here. And we're just going to start out with kind of a blank check. We know that the demand level, see if I can get over here to this, that it's normally distributed with a mean of 15 and a standard deviation of 6. See if I can draw a mu here. Okay. Now, we're trying to figure out what's the probability that the demand is going to exceed 20. So 20 is going to be out here someplace. It's to the right of 15. And we want to get the likelihood that it's more than 20. So we want to get this little part that's above 20 in here. Now the way that you do this with the normal distribution is you figure out what the standard normal value is. You take and convert this 20, you're going to convert it to a z value. So z is equal to the x value, which in this case is 20, minus the mean, which in this case is 15, divided by the standard deviation, which is 6. Now when you go through and do the arithmetic, you're going to get 0.8 and a 3 that goes on forever. Now the Z table is only good to 2 decimal places. So what we're going to do now is we're going to look at the Z table, and we're going to find the Z value for 0.83 and see what the probability is. Now I have the Z table. It's inside the D2L shell. I'm having to get used to this new type of input device. But if you look in Chapter 6, it's in the section for the Chapter 6 videos, and it's just called Cumulative Z Table, and I have places with 4 decimal places and 5 decimal places and 6 decimal places. Now what this table will let you do, one use of it, is you can figure out what the probability is that you're less than or equal to some value of z. Now there are 2 pages to this table. I'm actually on the 2nd page of this table. This is for positive z values. But the part that's shaded up here in blue is the probability that the z value is less than or equal to the z value that you're looking up in the table. Now the z values are on the margins. The probabilities are on the interior of the table. So if z was 0.00, the hundredths position designates the columns. But if you're right smack dab in the middle, the probability that you have a z value that's less than or equal to 0 is going to be 0.5. Now 0.83 as a z value is going to be to the right of 0. So to get what that probability, what that blue part is, we know it's bigger than 0.5, but we can look it up in the table to at least 4 decimal places. So we come down here and we're looking for 0.8. The 7881 is the probability that you'd have a z value that's less than or equal to 0.80. We got 0 in the hundredths position. The 0.7910 would be the probability that you'd have a z value that's less than or equal to 0.81. Now we want to get the probability for less than or equal to 0.83. So we come over here to where we have 3 in the hundredths position, and the number is 0.7967. So the probability that you get a z value that's less than 0.83 is 0.7967. Now if the probability that you're smaller is 0.7967, we wanted the probability that we're larger than 20, which in this case it's the same thing as having a z value that's larger than 0.83 after we do the conversion. So all you have to do to get the part that's on the other side is just subtract this probability from 1, because the likelihood that you're below it plus the likelihood that you're above it is going to equal 1. This is a continuous probability distribution, so there's no likelihood at all that it's going to be exactly equal to 0.83. Now I've already done this on side the other application. Let me put this application to the background. It's not letting me do it here. Get off screen here and see if I can do it over here. There we go. Now get back on screen. Go up here to my next slide. Here we go. Alright, now I'm trying to do this with 2 different colors. The probability that you're smaller or equal to 0.83 is 0.7967. So the probability that you're larger than 0.83 is going to be 0.2033. You just subtract it from 1. And this is the likelihood that you're going to have a stock out. So there's over a 20% chance that that 20 gallons isn't going to be enough. And that's not a good situation. So the next thing the manager wants to investigate is, I want to put a number in here that I like. I don't want this to be more than 5%. What's the value in terms of the gallons to where I get this number to be pretty close to 5%, but I don't want it to be more than 5%. I don't want more than a 5% chance that I'm going to have a stock out. So let me get up here to the top and pose the problem this way. What's the number of gallons for which there's only going to be a 5% chance that we're going to exceed this? Now, the Z formula says that Z is equal to X minus mu over sigma. But what we want to do here is to solve for the X. So you can take the formula, and it's a fairly simple algebraic exercise, to go through there and solve it for X. You can multiply both sides by sigma and then add the mean to both sides, and you've got a formula for solving for X. But in order to figure out what that number is, you've got to plug in what the mean is. The mean in this case is 15. You've got to plug in what the standard deviation is, which is 6 in this case. And then you've got to figure out, well, what's the z-value that corresponds to there being 5% to the right of this value. But what's the z-value that 5% of it's larger? Well, the table works on the other side. It works on probabilities that are less than or equal to. So we can get those numbers by just subtracting this one from 1. So let me see if I can get over to this next one. And we want to figure out what the value of x is so that we get 5% to the right of it. And you can just take the formula for z, solve it for x, and you come up that x is equal to mu plus z times sigma. And then we can plug in what we know mu is. We can plug in what we know sigma is. And we've got to figure out what z is from the table. But from this point, I can tell that the probability back here before x is going to be 0.95. And that should be illustrated on this one. There we go. I was clicking on the wrong one. So 0.95, we can go to the table and we can figure out what the value of z is. Now this kind of problem, I refer to this as an outside-in type of problem. We're looking on the inside of the z table for the 0.95. So let's go back to the table. That's in the, you can download this table from the D2L shell. But 0.7881, 0.79, the numbers get bigger as you go down. So let's see if I can grab this. May have to change to the mouse. Whoops. That's a little bit too... Yeah, I don't know how to use this well enough. Let me try this. Changing my device here. 9295. All right. So right in here, we're looking for 0.95. Now we have 9484, 9495, then 9505. So 0.95 is between 9495 and 9505. Now the 9495 corresponds to a z-value of 1.6, and up here we get the 4. The 0.9505 corresponds to 1.6, and up here we get that hundredths decimal places of 5. So we're looking for 0.95. Now what I want you to do in a case like this, it's not in the table, is just use the z-value for whichever one's closer. So is 0.9495, is that closer to 0.95? Or is 0.9505, is that closer to 0.95? But just pick the one to which it's closer. In most cases, one of them is going to be closer than the other one. But in this case, it's right smack dab in the middle. So when you run into a case like this, I want you to go halfway because it's easy. What's halfway between 1.64 and 1.65? It's 1.645. Just put a 5 on the end of it. But the z-value that corresponds to 0.95 is 1.645. And then we can go back there and do the arithmetic. So let me go back to the picture here, and we'll change it. So our Z value is 1.645, and then we can plug that in for Z, multiply that times the sigma value, and we come up with 24.87 when we do the calculation. And the closest whole number to that is 25. 24.87 is going to give you about 5% chance of exceeding that. So if you go up to 25 gallons, then it's going to be a little bit less than a 5% chance of exceeding that. And that's the solution to the problem. Now you also have formulas in Excel that you can do this with. So let me bring up Excel here. This formula, let me double click on it so that you can see what's inside there. This is using the standard normal. The S in the middle is a standard. But here I'm calculating the Z value. And then the 1 tells it that we want the cumulative form. You can type in true or false, but 1 is shorter to type than true. But we figure out what that Z value is, and this was our 0.83, except when you do the calculation, you're going to get 0.833333 forever. So the number that we're getting here, let me hit the escape out of this, it's not quite 0.2033. This is what you get with the table. Now I've rounded these numbers off to 4 decimal places. Actually this number would be a little bit different. But let me show you the difference in the formula here. This one I just put in 0.83. I just rounded the number off to the number that you'd have in the table and just use 0.83. True or 1 is the cumulative form. But the number that you get from the table is 0.2033. Now there's this form with the standard normal, but there's also another form of the normal that's available in Excel where you provide it with the mean and you provide it with the standard deviation, and it being Excel will go through and do this calculation for you. So I have that illustrated down here. This one we're just using the normal distribution. There's no S in the middle. It's not the standard one. You put in the value of X. We put in the value for the mean. We put in the value for the standard deviation and the fact that we want the cumulative version. So Excel figures out what the Z value is, and then it returns the probability. Now the function itself is going to give you the probability to the left of the point. But we want the probability that's to the right of the probe. So you take 1 minus. When you do the calculation, you just type in equal, 1 minus, and then get the probability that's to the left. Now to get the number that's in the table, what you have to do is round it off. And this is kind of an absurd way of doing this. I have to specify, if I use this version, I have to specify what the mean is and what the standard deviation is. Well, if I'm using a Z value, this is the rounded off Z value, then the mean is 0 and the standard deviation is 1. But that's what it is for the standard normal. And the 1 is just another way to say true. But you're using the rounded off version to come up with the answer. Now for the other problem that corresponded to the 5%, there's also an inverse function. Now this is the Z value that Excel has found for us. But this is using the standard. So I took 1 minus 0.05. I need the probability that's less than or equal to the point. And then this will return the Z value for me. But for 0.95, let me escape out of this. It's not 1.64, it's not 1.65, it's 1.644853627. And there are more decimal places. This is all that's shown with the general format. But what's really cool is Excel will do this calculation for you. You don't have to take the z-value and plug in the mean and plug in the standard deviation and go through and manually do this calculation. The form, not the standard form, but just the normal inverse will do that calculation for you. So we can come up with this number just by using that function. But I want the z-value that's going to give me the 0.95 probability when the mean is 15 and the standard deviation is 6. But it goes through and does that mu plus z times sigma for you to figure out what the number is. But you've got to remember that the probability that you put into the inverse function, it needs to be the probability to the left. If you want to get the probability to the right, you have to subtract it from 1 and get it in the form of the probability to the left for the functions to work. But Excel will do these kind of calculations for you.